it's because of exactly these things. Yes, maybe AutoML could win the Kaggle competition, but it's not going to help understand the practicalities of what's going on with the data and make a real world application.
The data science space really shifted, call it 2014, 2015, which just happened to align when we started the company. So it was very good timing. And, bringing GPUs to the market opened up the whole space of deep learning, where I want to see the industry move. And I think the biggest barrier for real adoption is the sharing of information across a diverse population.
Michael, welcome to the show. It's such an honor to have you back on the Super Data Science podcast. It's been a couple of years. I can't wait to hear what's been happening in those years. How's your day going so far?
It's going excellent. It's been busy. First month of the year has been very busy and hectic, but all things considering, it's going very well. How are you?
Very well, thank you. It's super cold in New York at the time of recording. We had the first lasting snowfall last weekend. And I imagine you're in Massachusetts, right? I imagine you have lasting snowfall for months.
Yes, until about end of March. You don't put away the shovels until like mid-April. And then we can have some fun once May hits.
Nice. Do you get into winter sports up there?
I do. I have skied my whole life. And then this past winter, I've convinced myself I was going to learn how to snowboard, but not like in a way where I was going to take lessons and do it responsibly. Like I was just going to buy a snowboard, get on the lift, go to the top and snowboard down, which I did. And it was an experience, to say the least. So now I'm going to take a step back and say, well, I probably could use an hour lesson to learn how to snowboard. So yes, I've skied my whole life, and now I claim to fall down on a snowboard.
I think that's a great idea. I have an identical story. My butt has never hurt so much as the day I tried to snowboard.
Yes, it was, but I've committed because I bought it. So I was like, now I've committed to this process for the whole winter.
Nice. Well, I look forward to hearing how that journey goes. How is your career journey going? So for those of the audience members who weren't listening to your episode from 2 years ago, tell us a little bit about what you do.
Of course. So I have the privilege of running a company called SFL Scientific. We are, about 6 years old at this point, and we are a data science consulting organization. So from day one of the company through today and into our future, we've always taken a very clear kind of business stance of forming SFL with this idea of being a consulting organization, which in our space is having all the fun of working on all these cool projects for other organizations that need outside help and expertise to solve their challenges. So, I have a team of really great data scientists, AI engineers that spend all day building algorithms in large scale data engineering environments and platforms for our customers that range from top Fortune 5 to the military and everybody else that needs that real kind of expertise in data science skills, and we get to supply that for them. So it's a great opportunity to work on a lot of interesting and novel projects.
Nice. And as a part of that, you have been distinguished in a number of ways. I think perhaps the most notable is that you've been the NVIDIA Partner of the Year for AI services a couple of years running now, which is a huge deal for people who aren't aware of NVIDIA, which may not be a majority of listeners. NVIDIA is arguably the premier chip maker today. Sorry to the Intel folks listening. But they've really taken off with GPUs, which were originally probably intended primarily just for rendering graphics, for example, for playing video games, for creating videos, like as a video editor. But they've taken off for AI and for mining Bitcoin. So I imagine more on the AI side. I'd love to hear the kind of work that you're doing with NVIDIA, Michael.
Yeah, so if you think about NVIDIA's perspective, the data science space really shifted, call it 2014, 2015, which just happened to align when we started the company. So it's very good timing. And, bringing GPUs to the market opened up the whole space of deep learning, right? And it's not that deep learning didn't exist before, but the computational horsepower to solve some of these networks, right? That was really the novelty of why GPUs were interesting and stay very interesting. So for us, you have to realize myself, my co-founders, and pretty much all of our employees, we came out of STEM specific academic backgrounds, right? We were all PhDs doing lots of fun type of work, but a lot of hard, novel, I'm going to call it R&D work, not R&D like you're sitting at a lab bench, pipetting all day, but R&D in the sense like it's novel in the sense you want to build something with AI at its core. So all of those projects mapped really well to saying, well, how do I solve this in a novel, interesting, hard way where deep learning can start really adding that extra layer. I can get now more accurate. I can make it faster. I can train these things better to perform better, more specific tasks. So back when we were starting the company and had grown the company, we latched on very quickly to NVIDIA because they were pushing the realm of possibility. And we said, oh, that looks really fun and looks like a great opportunity to go kind of pair to pair with them because at the end of the day, they make GPUs. They don't solve problems. We solve problems. We don't make anything. So in tandem, we said, ooh, that's a really good marrying. And we've kind of created this real strong partnership. So today, I mean, now, I don't know, 60, 70-ish% of all of our work is really in that space of, what can we create from an algorithms perspective that is in and around some GPU accelerated workload, right? This could be, a
Mm.
couple of years ago, it was only deep learning, but nowadays, right, you have rapids and all sorts of data science stuff that will have, from a machine learning or even like a graph database or all sorts of areas like that. So, we work on things as cool as, I don't know, transplants from a surgical perspective. How do you marry that up when you're thinking about it from a diagnostic and a transplant in an organ perspective, all the way to drones, all the way to autonomous vehicles and instruments and everything in between that you can imagine, because of obviously our expertise in the deep learning space, but also this kind of marrying of partnership that we have with NVIDIA.
That sounds really smart. It does sound like a beautiful marriage. Tell me about Rapid. I don't actually know what that is.
Yeah, so Rapids is
Ah,
just a
Rapids.
software library that NVIDIA put out, I don't know, maybe 2 years ago, something like that, which was their answer to only being a deep learning focused company, right? Because one of their challenges was like all of these organizations out there, most of them don't need the latest and greatest and most sophisticated thing that comes off the archive. That's silly. That's not real. Most of them are still using a lot of traditional statistics, math, traditional machine learning models that they said, well, I don't need you, NVIDIA, because these aren't GPU workloads. So NVIDIA says, well, what if I accelerated the traditional, I'm going to call it math and ML stuff by giving you this Rapids platform that would accelerate all of data science? So all your pandas, right? You're doing all the panda stuff, you're doing all the traditional ML stuff, all the, I don't know, the graph databases, all that. It's an accelerated for that stuff, which is different than just the deep learning side.
Wow,
Does
I
that make
learned
sense?
something. Yeah, 100%. I learned something today that I need to look into immediately.
Yeah, Rapids is a
Um,
great platform. And it's, like everything, it's free, it's open source, you do your thing, you integrate it, and it's great for projects.
awesome. This episode is brought to you by Super Data Science, our online membership platform for learning data science at any level. Yes, the platform is called Super Data Science. It's the namesake of this very podcast. In the platform, you'll discover over 2,500 video tutorials, more than 200 hours of content, and 30 plus courses, with new courses being added on average once per month. All of that and more you get as part of your membership at Super Data Science. So don't hold off, sign up today at www.superdatascience.com. Secure your membership and take your data science skills to the next level. Are you able to delve into any particular projects that you've been working with NVIDIA on?
Sure. And it's not that we necessarily work with them on it, right? We kind of go to the customer and the customer will buy GPUs that makes
Ah,
NVIDIA happen. And then they pay us
ah,
for our services. But, we go there as a strong team, right? It's a storytelling team. Um, some of the work that we're doing really spans across industry verticals. So, we can start, I guess, talking from a healthcare perspective. So historically, we've always worked quite a bit in healthcare, just because, again, we came out of STEM, so we were all kind of physicists and working in the space in general. So we have it's an easier talk track, right? When you're talking to researchers or talking to folks in healthcare, they really get the dynamics of the problem, and you can really map what they're trying to accomplish back to what you're trying to accomplish from a data science perspective. So some of the interesting work that we're doing these days is, really thinking about how do you use novel applications, right? Again, thinking about data science from a novel perspective to solve health-related challenges. So one of the big areas that we're working on nowadays is this concept that I mentioned it very quickly, like organ transplant. So a lot of our customers are these big hospitals, these big research hospitals that, about once every 2 weeks to once every month have, and it's a lot of this in the children's hospital will have children that need total heart replacements, right? So unfortunately, they're very sick. They need a surgeon to go in and basically replace their heart with a heart that, is now recently been expired and needs to be transplanted. You would think that medicine, and I'm not just talking about this use case in general, but medicine, and you would think is extremely scientific and people really know what they're doing and there's this science to it. But in fact, it's really archaic in the way that they approach it. And it's definitely much more of an art than it is a science. So a lot of our work is kind of trying to transition from art to science. And this is a really good example of that, where about 30% of all organs these days go wasted because they don't know how to properly match organ from recently expired, individual to organ of somebody who's alive and needs it, right? They don't know how to match that appropriately because they don't know if this heart in the heart cavity would actually match what this heart over here needs to be. Historically, they've only used things like body weight, right? Is your body weight roughly similar to this other one? And if it is, sure. But that is like, I mean, we're talking about like mean plus standard deviation dictating, will you get a heart transplant? Like, that's crazy, right? So a lot of the work we're doing now is to think about this in a much more scientific manner of saying, well, I know I can take ultrasounds, I know I can take MRIs, I can take CTs, where I can very, very accurately segment the entire thorax cavity and measure precisely what is that total cardiac volume available within this patient, such that I know amongst all the list of applicable organs, which one would be optimal and who to place into which child or something like that. So
Wow.
this whole dynamic nature of shifting it from just they weighed 30 kilos to, well, no, I'm now going to pass this through an expertly trained system to dynamically tell you who to use this organ on, should and hopefully will and does reduce that waste, right? Literally organ waste down from 30%. We're hoping to, in the single digits, which is phenomenal when you think about the outcomes. That's an example.
Yeah, that is a beautiful example. What was the percentage? I missed it. What is the percentage of organs that are wasted today?
Something about 30%. It's in that
30%.
arena. Yeah, it's a lot. It's more than it should be.
Yeah, that is incredible to think of all the lives that could be saved. I also wonder, this is just me thinking off the cuff,
Sure.
but in addition to just making use of all the organs, presumably by doing a more sophisticated analysis than just weight, by doing the kind of scanning that you're describing, you presumably by getting a better fit, the outcomes are better for the patients that get the transplants anyway, right?
100%. And it's not just about, here's the cavity, here's the organ, right? You could take that huge steps further in real pre-surgical planning, where you're also mapping the blood flow. So now you're also thinking about it from like a computational fluid dynamics perspective. So what is the optimal, once you have the heart, you're going to trim it, you're going to reshape it. It's not like you just shove this thing into the next body and you staple it and you say, go. It's a lot harder than that, right? So it's all about, well, how do you optimize the arteries, the capillaries, whatever, to match up correctly for blood flow and things like that. So the problem just exponentially gets harder, but you can start being smarter and smarter about all steps such that you can ensure that the thing not just works, but will work for more than a couple of years, right? So that's really the progression of sophistication that you want your data science to eventually get to and to be able to solve real large, big problems like this. And this is just one example of thousands in the healthcare space. But, this idea of really taking a very manual process and making it smarter, right? These decision support systems,
Mhm.
that's where the huge influence of kind of data science is going in a lot of these industries.
It's exciting to hear. Sometimes I don't know where I get this inkling from. Sometimes I'm like, all of the easy opportunities in machine learning have all been taken already.
Yeah,
But having a conversation like this helps me realize that there's still a crazy amount of opportunity that we're not going to
yeah,
need.
you're
Yeah.
scratching the surface. I think there's a misconception, and I think this is an important point to talk about. There's a huge misconception between what is solvable in an academic sense from an algorithm's perspective, the Kaggle competitions of the world, and what is practical in a real world scenario. right? Just because I gave you 200 perfectly annotated CT images and you downloaded them as your train and test split on Kaggle, and you can run your billion parameter segmentation algorithm, sure. But that's not how the real world works. The real work has implications that are so far beyond that, where your algorithm is 1% of the total solution, if that. So the applications of ML are so much more complex than just saying, here's an idolized training environment in a black box with perfect data. That doesn't exist in most scenarios. There are some companies where it is that easy, but those are really far and few in between, right? Right. Most real world data science problems in a true business context are never that trivial. Um, you can make them seem easy, but in reality, they're really not. And I think that's where a lot of these big companies fail time and time again. And that's why there's always this pushback of, is there really ROI to be achieved here, right? That's the big problem that we see in the space, because it's really that misunderstanding of this low hanging fruit problem matched with reality of outcomes.
That's beautifully stated, and it is a recurring theme that we've had on the podcast recently, not only with guests, but in my 5 Minute Friday episodes, where I talk about a topic or answer questions that I've had from audience members. And people working in data science have concerns about how future proof is this career. Is AutoML going to take over? And it's because of exactly these things. Yes, maybe AutoML could win the Kaggle competition, but it's not going to help understand the practicalities of
No.
what's going on with the data and make a real world application.
Yeah, I have a very strong opinion in that space. And again, I'm biased, right? Like everybody has their own biases,
You're
but
biased?
I'm
No
biased.
way.
Of course I'm biased, but like AutoML is, I mean, there's this analogy, right? Like I give you a calculator, right? Everybody, you were in grad school, I was in grad school. We all had these beautiful TI-89s. They solve complex integrals. You put all sorts of crazy stuff in that. By no means did that help me become a mathematician, right? These are tools in your toolbox. They made me multiply faster rather than me doing it on pen and paper, but they are just levels of tools to help make processes a little bit quicker in computation. Same thing with AutoML. The end of the day, that's not going to solve a novel challenge, or think about what are the implications of such challenges. So for teams that are sophisticated and can use that as a lever to just speed up some of their computation all day long, awesome. But that, again, that is the smallest sliver of the real problem statement. So they are great in context, but out of context, they're actually extremely dangerous.
Beautifully said.
And again, biased. I understand I'm biased, but that's at least the world that I see and we live in. Right?
You and I, we can use confirmation bias together to feel very comfortable with
That's
drawing
right.
these conclusions.
Of course, absolutely.
So that kind of work dealing with the healthcare system, that sounds like it's probably public sector work to some extent.
No, that's all private sector.
Oh,
So
it's all private sector.
that's hospital systems. So
Oh,
that's some
nice.
private hospital systems. Yeah.
I come from Canada, so I think about that as a public sector.
Yeah, if you guys everything. I understand. Yes, we're a little different down here.
But we'll use that to segue into the public sector anyway.
Sure.
So you have done a lot of public sector work. Do you want to tell us about some use cases that have happened in the last couple of years in the public sector, and how working in the public sector is different from working in the private sector?
Yeah, sure, of course. Yeah, so about 2 or 3 years ago, we started really gaining interest and attraction and moving forward into the public sector. And for folks who are listening and they don't really know the difference between public and private sector are all your for-profit companies. My company, Google's, Apple's, everybody of the world who's making money by selling you stuff, that's private sector. Public sector is all of the government institutions that we know about, right? Army, Navy, NGA, NIH, CDC, Smithsonian, all of these folks are public sector, right? They're all government run organizations. The public sector, we believe, because we would like to believe from a feel good perspective, are super advanced, right? Because we watch these TV shows and we see NCIS, they solve a crime like that. And that's beautiful cinematic representations of nonsense, right? Like that's not the way that the world really works, because the public sector, not that they aren't phenomenal at what they do, but from a technology perspective and a adoption of technology, they are laggards beyond anything that you would want to believe in. It's really the
Wow.
challenge, right? And this is where this whole kind of AI battle between China and the US and other countries become really, really difficult, is because our public sector is not nimble, not nearly nimble enough to keep up with the changing tech, right? Because they think about programs in the matter of decades, not the matter of months, right? And tech moves at this pace in the matter of months. So long-winded way to kind of set the stage. So what we wanted and what we are doing now is trying to be a bit of a change agent from the outside, from a commercial standpoint, and start working with some of these more advanced organizations within, I'm just call it DoD, right? Department of Defense or whomever, that is really looking to adopt some of these kind of new core technologies, right? These are, you might have heard of the Jake, right? This kind of centralized unit around AI for the DoD, or things like AFWorks or whomever, it doesn't really matter. So a lot of our work has been kind of adopting a lot of our commercial use cases, right, on the private sector into the public sector. That's the kind of the broad story. So for them, a lot of things are mission critical, meaning what can I do to affect a better outcome from a mission perspective, right? This could be geospatial, if you're thinking about it from a satellite perspective. This could be, things on an air force or an aircraft carrier or a plane, or things as simple as supply chain, right? How do I get stuff from, A to B? It's all very, very similar from the commercial field, but now mapped into the public sector. Does that make sense so far?
Unbelievably clear. You are an outstanding framer of, like, when you do a great job of taking a step back and framing why this is important. And then
Thank
on
you.
top of that, your ability to reel off specific examples without taking a pause to even think about it is pretty impressive. So yeah,
Oh,
yeah.
it's John, because I have to say this 30 times a day, and it's just practice. Let's not get fool
Uh,
ourselves.
very
Uh,
good.
but but in all seriousness, so a lot of the work that we're doing, some of the work that we're doing, I think, is of interest to probably this group. Is one of the big areas that I'm most passionate about, which we're thinking about from the DoD perspective, is how do we do things at the edge? Meaning, when I'm in an environment where I don't have my laptop connected to my Wi-Fi, or I don't have access to Amazon's P3 instances, and I can throw up a whole bunch of computes and sit around for 2 weeks and wait for results. So at the edge really means I have a autonomous piece of equipment. This could be a drone. This could be anything. This could be a vehicle. And I want to do AI at the edge on device. So, Tesla has done this fantastically. I think they are probably by far leaders in all of the AI space. You might not like them. I don't care about any of the politics there, but I'm talking about the fundamental technology of saying, I'm going to embed AI on a chip in a car, disconnected from the world, go drive. It's phenomenal. Think about that same application back into the government, right? We have drones, we have unmanned vehicles. This could be underwater, this could be on sea, or wherever, this could be anywhere. How do we think about doing AI at the edge to solve novel problems across data spaces? Meaning, there's a visual component. I want to look at what I'm seeing from a target perspective. Here's a person, here's a tank, here's some agriculture field.
Mhm.
And I want to start mixing that in real time with other spectral information, right? This could be electronic warfare. This could be thermal patterns. This could be RF sensing patterns, right? And the list goes on and on. But how do you do that in a highly congested way at the edge and do AI there? That's cool. That's amazing, right? And that's really where, especially in these kind of DoD specific applications, that's where they're seeing the technology have to be to make them viable and reliable, right, in the years to come. So if folks are looking to get into that space in general, there's a fantastic amount of work to be had there. And again, they're just literally scratching the surface so far. So there's a ton of opportunity from a career perspective, getting in and working on problems like that, which I believe are the next huge domain of real interesting topics.
Super cool. That is a great suggestion for people to get involved in public sector data science. I don't hear people expressing interest in that enough. And maybe it's because I'm in New York.
Uh, I'll tell you why. Sorry, I don't mean to cut you. The problem
Mhm.
is our government throws around money like it's nothing. $1 trillion here, $20 trillion here, but they don't pay people well because they
Right.
have some very clear schedules called the GSA schedule where folks like yourselves who, like, yourself, myself, a lot of your listeners who are really, really well academically trained, they have great credentials, they do all this great work, they can't make nearly of money that you can going to work with some of these big technology companies. So you've created this very large divide where, because of capital reasons alone, out of their control, they're not going to pay the same amount as you do in the commercial space. So it really depletes the talent pool and pulls people away. And that's the big challenge that we really face, is just that, in the bureaucracy of that. That's probably why you don't hear much people talking about it, because they're like, well, screw it, I'll go make 3x at Google. That becomes a problem,
Right.
right? So that's why. And that's the same reason we have a lot of people leave academics, right? Like, nobody wants to stay and be a 60K postdoc forever, where you could go make 300K at Google. Like, it's hard, right? It's a financial conversation.
Right. Um, on that note, though, on the note of, those are very practical reasons as to why people don't go. For whatever reason, the people that I have met that do work for
Yeah.
the Army, I spent time in Fort Belvoir in Virginia, and those folks were great.
Yes.
And maybe that's
Passionate.
related to passion
Correct.
and resources. The demographic was different. So I was teaching deep learning to them, and I typically I see a particular demographic recurringly when I teach deep learning at conferences or universities or data science academies. And it was so interesting to have people who were a lot older. In some
Yep.
cases, there were a large number of younger people, but there
Sure.
were people that had been working on neural networks for 30
30
years.
easily. Yep.
And those people know a lot, and they
Yep.
really know the detail. And
Right.
sometimes I'm talking about high-level TensorFlow Keras method calls, and they're like, "So,
Yeah. Let's
is
talk
this
about the
working
math.
like" Yeah.
Yeah.
And I'm like, "I'm gonna have to get back to you on that question."
Yeah. Of course. They want the details.
Yeah, exactly.
Yeah. I mean, that's the
Um,
beauty of it. Like, they're the folks that are in that space, they're there because they truly care, and they're extremely passionate, and they're deep, deep, deep experts, especially in their technology space. So yeah, they don't care about, this is the Keras abstraction, just make this call. They want to know the guts. And that's what they're excited for, and why, people that do get into that space, they're lifers. They're there for 30 years easily, because they're really passionate about that. So, if you don't, if I were somebody looking for a job in the space and making everything equally, I would definitely encourage that strongly, because like, that's where you're going to find some really, really interesting, cool stuff. Granted, you're going to have to want that. But yeah, that's a decision everybody can make for themselves.
I suspect there are also some scenarios where, even though you wouldn't be bringing home a huge paycheck personally, you might have access to enormous resources for particular projects and decades-long projects, like you're saying. So maybe a little bit slower moving to get going, but then feeling confident about having the resources for many years to come.
Oh, yeah. I mean, yes. I mean, that's the beauty of it, right? It is job security for life, basically. And I'm sorry, I don't want to paint a picture of like they pay you peanuts. Like, that's not realistic, right? But I'm saying, like, there's a inflation in the market that has
Yeah,
been
yeah, yeah.
set, especially by like Silicon Valley, that like nobody can really match. That's what I'm talking about.
I understand. All right, so that is the public sector, and that is super interesting. We've talked about private sector work that you've done, public sector work that you've done. What is your work like day to day? You obviously have a clear technical background. You
Yeah.
have a PhD in physics from Brown. You've done a lot of technical work. You can speak about this stuff, about any of the topics we've been covering at a reasonably technical level, as far as I can tell. So, what is your life like day to day as a CEO of
Gosh.
a scientific consulting AI company?
Fun, hard, dynamic, different. Every day is crazy. I don't know. I don't have a good answer for you, right? Like, because as in my role, I'll break it down a little to give you guys a little bit more understanding, right? Like, I can draw a line down the center of our company, meaning the front of that line is all about, how do we get projects in the door? How do we create relationships? How do we build an organization?
Mhm.
That's my responsibility. And then the backside of the company is my two other, co-founders, Dan and Mike, who I did PhDs with. They have the fun side, right? They get to do all the execution of the work.
Right.
And this is an imaginary line, because this is very crossed,
Of
right? So
course.
my day to day is very clear. How do we position ourselves as thought leaders, as experts in the space, and go to market with that to try to find new customers, to try to find new opportunities, to put out thought leadership, to come on podcasts, to talk to people, to run an organization. That's what I'm doing every day. Why that's actually really interesting, especially somebody from a scientific background, is it's not sales as in you think of sales, because my selling is I'm having extremely deep technical conversations with world-class experts on our client side, where it's not like we're just talking, oh yeah, let's just build this model and press play, right? Sure. But like, let's get to the meat of really what we're doing and stay involved as that thought leader and best in class perspective. So every day, I mean, I am talking to clients probably several times a day from literally every industry. I could have 5 back-to-back calls from automotive to agriculture to the army to healthcare, like boom, 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 like top person of R&D, innovation, marketing, right? Like it's so varied. And then I'm reading 2 archived papers on the latest deep learning methods. And then I'm writing SOWs on solving, I don't know, total cardiac volume estimation, right? Like it's everything, right? And then you do an all hands, and then you go home and play with your kids, right? Like, so it's really dynamic, but it's that dynamicness, which is very appealing about keeping you extremely up on all things that are happening in the tech space, because it's my responsibility to know that and bring that to our clients, while my other guys get to have fun and actually do all the work.
Well,
Does that answer your question, or does that paint a
it
ridiculously
no,
confusing
no,
picture?
it answers my question perfectly, and it also gives me a sense that your job seems pretty good. Maybe not as fun as Mike and Dan, was it?
Yeah, they
Uh,
have a fun stuff.
but yeah, your job
Yeah,
sounds pretty good.
it's fun.
Um, so I know that you have a lot of positions open right now,
Yep.
across the board. Any kind of data professionals, you've got an opening for them, and would love to hear from people with any kind of data skill set. So, what are you looking for in the people that you hire?
That's a great question. Um, for us, we are a consulting organization,
Mhm.
which is very, very different than a product organization. So for me, we look for people that can pretty much wear multiple hats, meaning they really understand the technology and how to solve problems. And 9 times out of 10, even when the client thinks that this is the problem and this is the data, it's really not the case, right? So you have to be really, really thoughtful about ways to solve hard and complex problems that, you might only have an hour and no background to think about. And all of a sudden you have to be that expert. So it
Mhm.
takes a lot of rigorous kind of thought around kind of algorithms and data and infrastructure, because everybody has something extremely different regardless of who they are, right? Just depending on what we're trying to solve. But you also have to be very curious and wanting to build the business case around that, right? Because like you're not going to just hire us to sit in a room and type on our keyboards all day long and then go home, right? Like our job is to do that, but then deliver that back to the client such that they can actually do something with it from a commercialization or a monetization. They have to do something with it. They have to justify paying us, obviously.
Yeah.
So it really is that extremely soft plus hard skills, where that soft skill, by and large, is probably the most important, to be honestly. How do you convey thoughts? How do you convey outcomes? How do you convey statistical measures to somebody who, frankly, doesn't really know and might not care, because that's not what their motivations on the other side of the house is, right? So it takes a lot of thought and just mind share around really what does it mean to deliver AI projects and to the customer, right? So it's really from a consulting perspective. Sorry, I didn't mean to drone on about all of that, but somebody that wants to be client facing, but also do all the hard work and write the code and then deliver that's what we look for in our consultants.
That response makes perfect sense. Certainly no droning. I do want to ask a little bit. So you mentioned the soft skills, and obviously
Yeah.
that is very important in consulting. But is there some kind of unifying technology that you look for across your hires? What I mean is, are there particular kinds of things? So, programming in Python is probably
Yeah,
something
of
that's very
course.
common. It
Yep.
sounds like experience with deep learning might be, or machine learning.
Yeah,
It seems like almost certainly you'd be looking for that in people that you hire.
of course. So both of those have to be for certain, right? So somebody who has, so I think about the world of data science really is 3 problems that you can ever solve. Really all that exists. Vision problems, right? These could be images, these could be video, this could be 2D, this could be 3D, it doesn't matter. Your ability to solve image-based problems, your ability to solve natural language problems and your ability to solve signal processing problems. And signal processing is, anything from financial forecasting to edge-based IoT and all the things in between. So what we look for people who not just, has done one ML problem on Kaggle, sure, that's great, but that's a great start. We look for people who are a little bit more generalist across those data modalities, but really understand how to go deep across all three of those. And not just doing it in a kind of quick academic sense, but what does it really mean to deploy things like that, right? What does that mean on Amazon? What does that mean from a GPU perspective? What does it really mean to take this and then put it on an environment from our customer that we might not know or control? So it really is this kind of broader, true, fundamental knowledge of the data science space, right? Think about data ingestion, modeling, data output, or model output, right? Knowing across those three big buckets is what we look for.
This again is a recurring theme with guests recently on the episode, is that a lot of people at top organizations like yours are looking for data scientists who can extend, at least to some extent, up and down the stack,
Yep. Yep.
having awareness of implementation in edge devices, in your case, cloud
Yep.
computing, and so on.
And we'll hire specialists. Like we have a team that specializes in the engineering side. And we have, some people we bring on who specialize just in computer vision, right? But like at the end of the day, why I said we're different than a product, it's not like you're going to spend the next 3 years developing just computer vision problems for, I don't know, the histopathology. And that's all you're going to do. Like, that's not it, right? Our projects turn over very quickly. So, you have to want to have a general sense because you're going to work on a lot of different problems. So, we might have specialists, but everybody at the end of the day will be well-rounded just by kind of entropy of projects, right?
Nice. That makes perfect sense. Are there particular skills? So we're talking about what you're looking for today. Do you think
Mhm.
that there are particular niches that people should be learning more about today so that they're prepared for the coming years of data science? I would suspect in your position, you get a really good sense of what's coming.
Yeah. Um, a lot of organizations are still very, very much at the POC stage, meaning here's some data that they've collected. Who knows how long it's taken them to collect them? Show me the technical feasibility of this use case, which is fine, right? Give me the data, give me a laptop, I'll sit down and I'll do the work. I'll code some stuff. I'll show you accuracies. I'll make you all these fancy rock curves and things like that. I think that's where 90% of data science and data science teams lives today, is in that space, right? I'm not talking about the Googles and the Facebooks of the world, right? Throw
Right.
those folks away. I'm talking about the real companies. Not that they're not real. Those guys are way too
Yeah,
sophisticated, right?
yeah.
We're not, those are the outliers. We're the anomalies. I'm talking about the bulk of the real world. Um, if you want to take the next real big step from there and say, where can I position myself as a real leader in the space, or somebody who has, almost guaranteed security in what I'm going to be doing, I would say, well, think about it now. Once we've proven that technical feasibility out, we need to move these algorithms into a space in production. So what does the inferencing implications need to look like? So thinking about it from that context, right? Assuming that I can show you technical feasibility, what does it mean to inference against this algorithm with net new streams of data that will drift as my model changes, as my environment changes, as all the complexities really start to take charge? And think about it there, right? This is not just trivial, not that ML ops is trivial, but I'm not trivializing it by just saying, oh, we're just going to watch it and hope that it drifts. No, no, no. About serious thought power around how am I going to deploy these algorithms in a complicated environment where I have to be inference first in my perspective and working backwards there. That's where I would focus. That could be at the edge, that could be on CPUs, that could be GPUs. It doesn't really matter. It's still that mind share around that from the outcomes perspective and integrating it into your final product or wherever that's going to sit. That's where I would focus and spend a lot of my time upskilling, because very, very little people are there currently.
Beautiful. That is such clear advice for our listeners, and I think spot on, 100%.
So,
All right, let's talk a little bit about your journey to where you are today. We've talked about where you are, and we've
sure.
talked about how where you are is helpful for seeing what's happening in the future. Let's talk a little bit about your journey. So you
Mm,
did a PhD at Brown in physics. It sounds like your co-founders were doing PhDs at the same time.
yes.
Um, and so what was your journey from
Yeah.
finishing the academic work, and maybe even, even while you were doing your academic journey a bit, was there a sense that you wanted to be doing this kind of
Yeah.
data science consulting then?
Yeah. So everything from early on in my career kind of led us to this point amongst all myself and our co-founder. So we were extremely fortunate to be, I mean, everything's about timing in this world. It's great, right? Like timing's everything. So I had the wonderful fortune to be part of Brown's high energy particle physics group that was part of the Large Hadron Collider at CERN. So
Yep.
CERN, the
Yep.
largest particle collider, blah, blah, blah. I was part
Mhm.
of a group who I had a professor, Meenakshi Narain, who's just brilliant in the space. And basically, we were doing data science. This is like 2008 to 2012 at a particle collider before data science took off in the commercial space. We were doing it kind of from an academic standpoint. So, we're talking about petabyte scale data collection and machine learning, right? This is before deep learning, machine learning algorithms on these extremely complicated rare signal events, building algorithms, doing analysis, doing all this stuff for years and years and years, which then, right when we were graduating, led to the discovery of the Higgs boson, which won a Nobel Prize. I got to be a part of that team. I was on the analysis team. My thesis was actually on the
Wow.
analysis that went to win the Nobel Prize for the theoreticians and things like that. So, I mean,
Wow.
just right time. Like, listen, I didn't do anything, right? Like everybody else, the world, the community did everything. I just happened to be very lucky. And my professor said, "Hey, Mike, what do you want to do?" I said, "I want to do that," and that was the good thing. Same kind of story with my other co-founders as well. So coming out of school, we had this real understanding, not full understanding, but starting this understanding of, wow, this data science space was really starting to take off. This is 2012, right? And we said, okay, that was cool. And we like that. So we all went and worked for a couple of years, and we're very, very close still, as we got out of school. And we said, okay, we want to really take our knowledge and our passion for solving hard data and hard algorithms problem. I didn't say big data, I said hard data problems and hard algorithms problems into the commercial space, right? Where all these companies will have all these problems and challenges, and we could be like, "Oh, we're so smart, hire us," right? Like that's the naive approach. And we
Yeah,
said,
yeah,
"Okay,
yeah.
let's try that," and we did, and it worked. So our kind of passion towards some of the problems that we were doing from day one of PhD kind of materialized into now what we do every day for our clients, right? Back then we were doing it to solve kind of fundamental physics problems, but now we're doing it to do things like better drug discovery or drone applications or, what is my crop yield of my agriculture farms and things like that. It's the same problem, it's the same solution. It's just the abstraction of what you're calling it has changed, right? What we do today to find better cures in medicine is literally the same thing that we do to find rare signatures of particle decays and particle accelerators, right? It's just all the abstraction of the logic that humans put on it, not the technology, not the data. So that's been the journey, and that's what we're passionate about, and why it's fun, because we get to really pick that journey and stay in kind of top of all these fun problems.
Beautiful. Are there any particular people that influenced you or continue to influence you today? People working in the data science space, or maybe entrepreneurs, or something that you kind of look up to and think, this is a really great example of where I'd like to be 20 years from now, or something like that?
That's a good question. Um, my biggest influencers, not from a entrepreneurial space, I guess, was definitely my two advisors, both in undergrad and in grad school. They were incredible, brilliant professors, and they really kind of set that cornerstone of, I think how I envision what real rigor in problem solving looks like, and then I've hoped to encapsulate that in myself and in the company and my employees and such. So they by far them. Um, when I think about it from who do we aspire, who do I aspire from this side of the house, up until like 3 weeks ago, I would have said nobody, because like I personally am not somebody who's driven by looking at other people's successes as a motivation. Like I just never
Mhm.
was, it's just not me personally, right? Like it's just not what drives me. But recently I just got I read Bob Iger's book. By read,
Mm.
I mean listen. I don't read anything, right? I listened to his book. So Bob Iger's now like 20 years at CEO at Disney. Um,
Mhm.
and the story that he told about the innovation that he brought to a company like Disney, where 20 years ago basically was on the brink of disaster. Like they were losing money hand over fist from all their parks and their movies. They were all flopping. And he was this huge change agent that came in and said, guys, listen, we have to innovate or die. And, risking billions and billions and billions of dollars, like him alone was like, I'm going to put the stick in the ground. I'm going to do this by acquiring the Pixars, the Marvels, the Lucasfilms of the world, where everybody else says no. And he's like, no, I have a vision that is so forward thinking. Was just incredible, that story. And now you see it, today, 20 years later, it's like, oh yeah, no shit,
Mhm.
buy Marvel. Like, yeah, like
Mhm.
20 years ago, that wasn't as obvious. So to me, that was really inspirational. Just like, wow, like that's one person with such huge effects on like what we all now do and love. And it seems so obvious. That was a big one. So I would, I guess, point to Bob Iger.
Beautiful. Great answer. I love that. So, with your perspective, uh, doing this cutting edge scientific consulting, seeing so many different pieces of the puzzle across the public sector, the private sector, and so on, I have a question that I haven't asked a guest on the podcast yet, but I've been wanting to ask,
Sure,
which is
hit me with
something
it.
that I think about a lot. So, thanks to ever cheaper data storage, exponentially cheaper data storage every year,
Mhm,
exponentially cheaper compute.
mhm,
Um, you know, Firms like NVIDIA allowing us to do
yeah,
compute at a huge scale cheaply. Ever more abundant sensors, especially with 5G coming out, that's going to accelerate even more in the coming years.
yeah,
Obviously, unparalleled interconnectivity and data modeling innovations. You mentioned archive, people sharing things in archive, at conferences at light speed with each other.
yeah.
So the technology in machine learning and data science advances exponentially every year on all of these fronts. So, is there a particular vision of the future that you get excited about for you in the coming decades, or maybe for your kids?
Yeah. Oh, my kids, that's different. Um, the vision of the future. I would love to live in a world. So to your point exactly, right? Like I have a slide that actually says exactly what you're saying, right? What are the drivers for innovation? Why invest in data science? It's usually four main things, right? Like, the data sets are now larger, data sets are more diverse, technology is now more accessible, and algorithms are basically open source and constantly evolving.
Hmm.
Those things are all great. I think one of the real at the core where I want to see the industry move, and I think the biggest barrier for real adoption is the sharing of information across a diverse population. As a great example, I'll give you. Think about back to this chest segmentation I was talking about, right? This
Yep.
estimation of total cardiac volume for more transplants. Currently, all we have is one hospital supplying 200 labeled patient data, 200 people in the entire population, and we have to build models about that. And these other hospital systems says, I want that. But because of all these privacies and governance and all these rules and regulations, we can't just openly discuss and share information and data because of all the red tape we put on everything. And that's really
Mhm.
why the public sector is crazy difficult because of all the red tape. So if we don't get to a place where we've created communities and mind shares to share information such that it's not just 200 patients, it's a 200,000 patients, and build models that can actually attack that generalized problem, we will, I believe, quickly plateau in on our innovation because we're going to analyze all the data that's siloed in our specific company. And it's going to be like, now what? Let's make faster GPUs. Sure, but we don't have anything net new to learn. We only can learn it faster. It's very different. So I would love to see the world where we start to open up the floodgates of more information sharing, especially, I'm not talking about to sell you more ads and crap like that. I'm talking about solving hard problems that will affect outcomes, right? Health outcomes, energy outcomes, financial outcomes, things that will make the population better and save lives and extend lives, right? That's what I think about with my son and my future children after him is what can we do today to make his life better? And I think information and data sharing has to be at the core of that because we will make very fast, very cheap stuff. But again, that's just faster and cheaper. That's not solving the problem.
I've heard that, or read that because of COVID, some of these issues are becoming obvious to people
Yes.
who might possibly be able to make real changes. So
Yes.
public leaders might be able to make changes here because it sounds like you know this better than me. But things like if you're a big hospital system,
Yes.
then very early on in the pandemic, you had a lot of data on, oh, this is someone we need to intubate, this is someone we shouldn't intubate,
Yes.
various treatment options. Whereas a smaller hospital system, people are dying because
Yes.
they don't know how
I
to
don't have that
treat like the
information.
big ones do. Yeah.
Correct. So we'll see. What's really interesting, and this is by no means a political statement, nor do I care about anybody's politics, but from a Biden administration perspective, he theoretically could take a large stance because right now would be a very opportune time to say, listen, we want to put data sharing and algorithms and AI at the cornerstone from a federal mandate perspective and open up. And it's not something you do in 4 years or 8 years. Like this is a momentum building activity that would take a long time, but start that train moving. And like now, coming in fresh with all of the policies that are available and kind of the pandemic to say, listen, let's start this today. There's really no better time or better kind of activation energy than right now. So it could happen. I don't know if it will, obviously, but yeah, we'll see. But to your point, that's exactly what I'm referring to is making those kind of large legislative differences.
Nice.
We'll see.
Thank you for all of these substantial data science guidance today.
Oh, geez.
We have one last question that we always ask
Hit me with it.
guests. Yeah. Do you have any book recommendations?
I told you mine, Bob Iger's book. Read it.
Oh, yeah,
What is?
of course.
I don't even know what it's called. Something. Just look it up.
That's okay.
It's
We'll
awesome.
put it in the show notes. We'll find
Yeah.
Bob Iger's biography. We'll make sure with you that we get the right one. And
it's
we'll put
kind
it
of
in
a
the show notes.
biography businessy mix where he kind of talks about his journey at Disney, but you get some background and some perspectives of what he's done. I just found it very fascinating as like, wow, this guy's really an innovator. So yeah, that's the one I would suggest.
Cool. So, how should our listeners follow you or keep in touch with you to continue to get great advice like you provided over the podcast?
Wow. I am the worst followable person. I don't have much of a following presence. You
I don't
please.
know. I've seen you have. I mean, you have a
Yeah,
a
I have a team of people that
non-negligible
post
number.
for me.
Oh,
No. I sometimes do mine. I'm obviously on LinkedIn. If you want to know about us, come to our website, which is being updated. But follow us, follow me, follow on
SFL
LinkedIn, the
Scientific.
company, and things like that. I know we have a Twitter handle and things like that, but I don't think we use it. So it's definitely
LinkedIn.
less in your face. I would say LinkedIn for sure.
That is also a common thread across my guests. I think every single guest that I've had since I've taken over the Super Data Science podcast as host has said LinkedIn is the best way to get in touch.
Yeah.
Perfect. And people should be getting in touch if they're interested in consulting work at the cutting edge. It sounds like you're doing the most exciting projects out there. You have the best partners out there, and you have tons of openings. You did when we were talking about this before the show, it was like data asterisk is
Select star.
exactly.
Just come on. If you like this space and you have skills in this space, we are open to conversations at all times of the day.
Well, yeah, it sounds like great work. All right, Michael, thank you so much for being on the show. I hope we have you on again in a couple of years, and we'll catch up with all of the exciting new case studies and technological advancements that you've had in that time.
Awesome. Thank you very much. And anybody, please be in touch. Happy to talk about anything you're doing or opportunities that you may see or we can help with. So thank you, everyone.
Perfect. Michael Segala is intimidatingly intelligent about such an absurd number of machine learning applications. Or at least he would be intimidating if he weren't also so bloody friendly. Leveraging his rich AI consulting experience, in this episode, Michael enlightened us on how we're only scratching the surface of the opportunities to apply machine learning models in the real world, with huge medical and societal benefits in the coming years, such as by predicting the ideal donor organ for a given patient. How being able to convert proof of concept data science models into actual real-world implementations is an almost infinitely large commercial opportunity in the coming decades. How edge computing of deep learning models on vehicles like Tesla cars, surveillance drones, and submarines are revolutionizing the application of machine learning. How policy-enforced silos of data are holding back innovation across machine learning areas, but particularly in medical applications, and how needless deaths during the COVID pandemic may finally change this long-standing policy. The pros and cons of working on data science projects in the private sector relative to the public sector, and the 3 deep learning fields you need to have at least some expertise in to work at an elite AI consulting firm like SFL Scientific. That's machine vision, natural language processing, and signal processing. As always, you can get all the show notes, including the transcript for this episode, the video recording, any materials mentioned on the show, and the URL for Michael's LinkedIn profile at superdatascience.com/447. That's superdatascience.com/447. If you add Michael or me on LinkedIn, it might be a good idea to mention you were listening to the Super Data Science podcast so that we know you're not a random salesperson. If you enjoyed this episode, I'd of course greatly appreciate it if you left a review on your favorite podcasting app or on YouTube. I also encourage you to tag me in a post on LinkedIn or Twitter, where my Twitter handle is @JohnCroneLearns, to let me know your thoughts on this episode. I'd love to respond to your comments or questions in public and get a conversation going. All right, it's been a blast. Thank you for listening today. Looking forward to enjoying another round of the Super Data Science podcast with you very soon.